Hey guys, welcome back. So what we're looking at today is 7.2, circle dilations. So let's go ahead and jump right in. All right, so what we're looking at here on this first part is we want to find the missing angles, rotational symmetry, and regular polygons. So find the missing angle in each of the figures below. So we have a triangle here. We know a triangle has 180 degrees, so we're going to subtract the 93, and we're going to subtract the 65. So when we take 180 minus 93 minus 65, we end up with 22 degrees. So there's our solution. All right, number 4 obviously has a lot more going on in it, yes? Oh, yes. So we have two triangles here, and we have 3 different values that we need to find. So first and foremost, we have S here in a triangle that already has 2 angle measures. So we can take 180 minus 90 minus 35. So if we take 180 minus 90 minus 35, we end up with 55. So S is 55 degrees. Now, R and S together are complementary. So we take 90 minus 55, which is going to give us 35. So R is 35. And we did 90 minus 55 to get 35. Now, if this angle here on this side is a right angle, then this angle over here is also a right angle. Now, another way to solve for Q is we think about it in terms of the big triangle. So 35, 90, and what? So that's another way to think about it, which, didn't we already have 35, 90, and 55? So our answer here is 55 degrees. So finding those missing pieces using what we know about triangles and their different properties, or about parallelograms and triangles, to take and solve these. All right, the next section. Find the angles of rotational symmetry for the regular polygons. Rotational symmetry means that the polygon rotates the indicated number of degrees to land on itself, and all points in the image coincide with the pre-image. So basically, to find this, we take 360 and we divide it by the number of sides. So in this case, we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. This is an octagon, so we take 360, we divide it by 8, and so it's going to be multiples of 45 degrees. So those are the angles of rotational symmetry. Every 45 degrees, that would be one angle, which is every turn of this. So all the sides would line back up. All right. For each set of similar figures, complete the proportionality statements. So we are actually going to take a look at number 8. So we have AB over arc BC equals what over arc B prime C prime? So the arc is the curve of this circle. So it's saying arc BC and arc B prime C prime and AB and A prime B prime. Those would be the proportional parts here. So similar is your key word for this lesson, similar. Now here we have arc BC over arc B prime C prime. So here we have a couple different things we could choose because it's not giving us anything in the other fraction. We just need our other part of the ratio. We just need to figure out something that has that same ratio. So we could say side AB and AB prime, or we could say side AC and AC prime. So I'm going to go with AC over A prime C prime for mine. All right. The next one is a little tricky, so I'm going to do it with you as well. So we have arc EF over something equals GH over CD. So GH and CD are this here, and we have arc EF, so this right here, goes with what? Arc AB. So arc AB. Now, the circumference of the large circle over the circumference of the small circle. So we're looking at the circumference of these. So we could compare it to the perimeter of large quad over perimeter of small quad. But with this, once again, there's all sorts of different possibilities. You could pick any individual line segment from the quadrilaterals to compare. You could compare the perimeters. Lots of different possibilities here for this similar figure. All right. Find the line of reflection between the image and the pre-image. So looking at number 10, from Z, we go up 1, 2, 3, and over 1, 2, 3. So it's 1 over 1. So if we go up 1, over 1, up 1, our line of reflection, we'd go down 1 over 1 from each point from here on down. I'll make this bigger so you can see. So we have this point, this one, here, here. So this line that I'm making, this dashed line, or dotted line I should say, would be our line of reflection between the two. So remember, we want to find the slope between two corresponding points, and then we do the opposite reciprocal. So the slope between z and z prime was a positive 1 over 1. And so the slope so the opposite reciprocal of that would be negative 1 over 1. So that's how we got that line there. All right, find the center of each circle. Hint, rotations happen on circles, so finding the center of a circle is like finding the center of rotation between pairs of points on the circle. So we're going to use the chord. So a chord is a line segment that goes from one side of the circle to the other without going through the center. So we would extend these out. So extend that out there. Extend that up there. Now we're going to draw a line that goes right through that. And right through this side. And right through this side. So right here is our center. So on 13, you'll draw your own chords and then extend those out to help you get the center of the circle. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.